Today we're looking at a new welder. This one is made by the guys over at DecaPower. And I'm going to be honest with you guys, when I first received it, I really was not that excited to make a video on this. And the reason for that was because I've had a DecaPower welder in the past. I want to say about 3 or 4 years ago. It operated pretty good, but there was a couple things that I didn't like, and I'll go through them as we go through this welder. Now, they sent me this a couple months back, and since then it sat in the corner of my shop, and I was moving things around and I saw it and I said, you know what, I think I'm gonna open it up, see what's inside, give it its fair shake, and finally make the video on it. But looking at everything that came out of the box, I'm actually kind of upset that I didn't open this up sooner. So let's go ahead and jump right in. I've got it all laid out on the table right now, and there is just a bunch of stuff. So this machine is the Fusion PMCT205BV. And so I think they have another PMT200, so this is like the bigger version. This is a dual voltage machine, so it actually comes with a 220 to 110 adapters, which is nice because, as you guys might know, I run everything on 110 volts because that's just what my shop is wired to. I don't have any kind of 220 in here, so any functions that rely on the 220 are completely useless to me. Typically for these multi-process welders, you'll tend to receive everything to do MIG and stick, but you don't actually receive this stuff to do TIG, and this one can actually do plasma cutting. And as I was opening this up, I realized that this not only came with a TIG torch, it actually came with a plasma cutting torch as well, which is actually right here. So right off the bat, those are bonus points on my end for sure, because I'm tired of seeing welders online that advertise a bunch of stuff but don't come with the stuff required in order to actually get everything to function. Along with the 2 torches, we also have the MIG gun, which is pretty standard. We have an instruction booklet. We also have a secondary liner, and that's going to be for aluminum wire and a spool gun. So we'll be looking at that a little bit later. And next to that, we've got a bunch, and I mean a bunch, of funny looking orange hose. So jumping over to the back, this is where we have the meat and potatoes. So we have the standard power on off switch, and it's actually flipped on. I'm going to keep it on off right now. We've got the power wire. We have these mounting studs for the air regulator, which does come included. It has a little mounting bracket that you can put on the back side of this welder and then mount your regulator right on the back of your machine in order to run the plasma cutter if you're going to actually access this feature, which I don't know why you would pick this machine if you weren't going to use the plasma cutting feature, but it's nice to know that you have a mounting spot right on the back. So if you don't want to run your air from a regulator that you have on your shop, you can run straight shop air to this regulator and then feed the back of this machine. Before we talk about the air fittings, we're going to talk about this 2-pin connector. These are going to be the trigger wires for your TIG torch or your plasma cutting torch. So you're going to hook it up right here in the back and then run the 2-pin connector in here, select the option on the machine, and you'll be able to trigger the machine with those 2 wires, which actually makes me wonder something about the TIG function on this machine, but we'll talk about that a little bit later. Now, I mentioned this twice already, but the old DecaPower welder had a regular barb fitting here on the back for your gas, and I did not like that at all. For those of you that have watched some of my review videos in the past, you guys will know that I do not like when machines do not have a regular gas inlet, a standardized gas inlet. That if you see that it doesn't have a regular fitting like this one right here, don't get it. So the previous DecaPower welder that I had a regular barb fitting. I spoke with tech support. I said, hey, I don't like that. I don't have any hose that's going to work on that barb fitting, and I'm not going to go out and change my whole setup just because you guys don't want to run a standardized fitting. And they were like, well, this is like the standard way that we do it in Europe and this and that. And then after that, that kind of left a sour taste in my mouth. So when DecaPower reached out a second time for this machine, I was kind of on the fence on it. I was like, am I going to deal with the same thing? They were very, very persistent that they said, no, you really got to check this machine out. We think that you're actually going to like it because so far it's looking pretty good. But the proof is in the pudding, and we're going to have to set this up and start making some test passes. After a 2.5-hour drive, we've just arrived at the No Bolt HQ here in Southern California. Earlier we mentioned that I wasn't able to run the maximum settings on this machine just because of the limited 110 power that I had with my generator. So we hooked up this 220 240 volt extension cord up into the wall, so we have no limitations on the generator size. And the machine right now is tricked out with all of its attachments. Just a quick overview before we get started. So this machine comes with a double drive roller, which I've never seen personally. Every single machine that I've had has only had one drive roller, usually a section like this big, and for whatever reason they thought it was a good idea to put two. I'm not sure why. It is an interesting choice, but they decided to do that. We went ahead and dropped in a spool of 030 MIG wire, and then we've hooked up the power wire to the TIG, MIG, and stick section right here on the right. It looks like if you want to use the plasma cutter portion, you have to take this guy and hook it right there. On the back part, we talked a little bit about the air fittings, and we've got one line that's going to go to an air regulator. This one's going to be hooked up right here, and then from here to the air compressor. On the left side, we're going to take another orange hose, which we've actually got right there for our C25 tank, and that's going to go on this side of the welder right here, and hopefully that's going to allow us to MIG weld, but we are going to find out. Then we've got our connector for a TIG torch, and the machine currently right now is turned on. So we're looking at the main screen right now. It's on high frequency TIG. Let me go ahead and change that. We're going to actually start off with the stick welding, so that's going to be the MMA with the little stick welding icon, and it looks like it's at 50 volts, 180 amps. That's actually maxed out, I believe. Let's turn that down so we don't melt a hole in its floor. I believe 65 amps should be a good starting point, and the voltage, we can ignore that completely because this will vary depending on the resistance that the stick is going to see through the material. So the only thing we're looking at are the amps for the stick welding portion. So that's pretty basic. Stick welding is electrode positive, so we're going to install the stick welding lead on the positive. The ground clamp is going to be on the negative, and now we're just going to set up a piece of material, grab the stick, and see if we can get some welding done. So we're going to be welding these two pieces of 1-inch square tube. As you can see, very realistic, very DIY. We're not going to be doing a whole lot of cleaning because I know that you guys don't do a lot of cleaning yourselves, so I'm not going to try to present something that I wouldn't just go and do myself. Sometimes if I'm fabricating something for the house, this is what it looks like. If it's something important for a vehicle like a cross member or something thicker material that I don't want to have any kind of porosity, then we'll go through and we'll sand it and we'll clean it properly. But this is probably as realistic as you guys can probably get it. I just hit it a little bit with a little bit of red Scotch-Brite and we were good to go. The stick we're going to be using is a E6011 by Welder. This is an 1/8 inch thick stick, and it looks like this guy right here, very cookie cutter. You'll be able to find these pretty much anywhere. So enough of that, let's go ahead and hook up the ground clamp and see if we can get some welding done. I think that'll hold. Yeah. Some little Afghan guy in a different country will probably be very, very proud. Okay, as mentioned, this was the 1/8 inch thick stick. We started off at 65 amps, then I went up to 75, then I turned it back down to 55, but it didn't really change the profile that much. I feel like there's some areas that came out fairly decent, like right there, but overall it just kind of looks like a poor stick weld. I should have prefaced this, but I'm not exactly a world-class stick welder. I'm more of a MIG kind of guy, like I'm sure a lot of you guys are. But if you guys need to, at least you know that it does have plenty of penetration. If you take a look at the bottom right corner on this side and the bottom left corner on that side, you can see the material pushing through. You can definitely tell that there's plenty of penetration on this 16 gauge material. I'm sure if we had thicker material and maybe even a little bit thicker, ouch, I just stabbed myself. I'm sure if I would have ran a thicker welding rod, I would have been able to get a better profile, or if I was just a little bit more proficient at stick welding, we'd be able to get it to look a little bit better. But overall, I'm not unhappy with the weld. I'm pretty sure it's strong. I'm sure it would hold up to whatever you need it to, especially for 16 gauge. There's not a lot of use for 16 gauge where you really need like a heavy duty weld. So if you just needed to get it done and you had some sticks and you had a little bit of experience, this machine will probably do whatever you needed to do in terms of stick welding. So now let's go ahead and see if we can try some of the plasma cutting. So we've got a little bit of behind the scenes action here. As you can see, we had some plasma cutting consumables and we've already seem to have blown them up. So let's go ahead and walk through what we did to set it up, and then I'll let you guys know where we're at right now. So we've got the included air regulator here on the back. We've got shop air going to it. It's sitting at around 75 to 80 psi or so. That's using the included quick connect hose right into the back of the machine. We've got the MIG hose here disconnected. We've also got this 2-wire connector hooked up. This is for the trigger on the plasma torch. Moving over to the side of the machine, we have to flip the connector from the MIG setting over to the cutting setting. So we've got the TIG MIG stick right here on the right. That has to be moved over to the cut. I accidentally did not do that on the first go around, and we blew something up, so make sure you do change that. And then jumping here to the front, we have to change it over to the cut HF. HF stands for high frequency. So what I realized was that this did not have a pilot, and you actually have to touch or get very close to the material before the machine will start cutting. And we've set it up to cut 50 amps, and then you can go 2T or 4T. 2T is where you have to hold the lever. 4T is where you touch the button once, and then you have to touch it again to turn it back off. And then the right dial does nothing, and the left dial changes your amperage. So for the amperage, we just turned it down all the way to the bottom, which is 20. It does a maximum of 50 amps. From there, on the bottom, we've got the earth clamp or the ground clamp. That's actually one of the positive. Apparently for plasma cutting, the machines are set up for electrode negative, so that means the torch is negative, the clamp is positive, and then the power clamp has to go into the negative portion of the machine. The plasma torch itself has to go into this fitting, just hand tight underneath this connection here. And then we have both hoses going through this sheath, going all the way out to the torch right here. And now, showtime. Okay, so after a little bit of fiddling, we kind of figured out what we were doing wrong, or not necessarily wrong, but wrong for this application. So we had the machine maxed out at 50 amps, and we were getting some weird problems where we blew apart one of the cups in half, and you could see that it did not like it very much at all. So when we were going through the settings and I tried to actually turn it up higher, I realized that we were maxed out at 50 and then our minimum was 20. So when we turned it down to 20, this is kind of what we started working with. And so then from there, we were actually able to turn it up. So from here forward, we did 25 amps all the way to the end. And then we flipped it over and did 25 amps on the opposite side. And so far, I mean, it looks like a pretty clean cut to me. So now that we verified that the plasma cutter actually does work, and it works on 16 gauge fairly well, we're gonna go ahead and step it up a little bit. I believe this is 1/8 inch or maybe a little bit thicker. And then we've got like 3/30 seconds or 5/30 seconds. I believe it's 5/30 seconds. And then we have 1/4 inch right here, or about like 7 millimeters or so for the guys outside of the United States. And so we're gonna go smallest to largest and see just where exactly this machine stops, if it does stop at all. So let's go ahead and we're just going to fasten this guy to here and just start cutting off some little pieces. So the first piece of plate that we're gonna cut, we're gonna start off at the 25 amps, and then I'm going to go ahead and just start going up and up until we get to a comfortable setting. So 25 amps, go ahead.
Got my leg here. Oh yeah. That was definitely going through. I think that was my fault.
It's really hard to kind of balance yourself and cut at the same time. I was mentioning earlier that there is a guard that you can put on your plasma cutters, and that kind of holds a certain distance away from the workpiece, and you're able to cut and balance yourself a little bit better. It's a lot more difficult trying to do it freehand, but we can definitely get better at it. Oh yeah, oops. I think it what? Yeah, this one cut all the way through right here on the right hand side.
Yeah, maybe 25 would have done it even.
You probably would have been able to go through. There is a little bit of dross on the back side of it, so you'd have to clean up the pieces pretty well. But that could also be an air pressure issue, either too much or not enough. We can fine tune that as we get better at it, but as for cutting, I think it does a pretty good job at 35 amps. So this one's like 5/32, I believe, not quite 1/4 inch. I think we're gonna start at the 35 amps and then move up from there. Oh, it's gonna need a lot more than that. All right, I'm gonna step it up to 40. Same material, now we're at 40 amps.
It cut through. I think it's just a little bit on this.
On the end right there.
Kind of like more of
a little bit thicker.
Yeah.
Only a little bit of dross.
Oh,
but
it cut through good.
It did. The other side kind of wanted, or on the 35 amps, it kind of wanted to work itself through. You can see the spots right there, but it didn't quite work. With 40, it definitely went through.
It felt better. It felt easier to control.
Oh yeah, a lot less dross, especially toward the end. And it cut it. It's not like it was a questionable. For sure, 100%. I think it just needs a little bit of fine tuning on the settings. But as for whether or not it cut it, I think it cut it. Now the last one, 1/4 inch. So we're gonna start at the same 40 amps, 60 PSI, 1/4 inch plate. Go ahead. Ooh, that was almost a clean cut. Oh wow.
Pretty close.
That was, and hardly any dross. You want to turn up the amps, or you?
Let's try it like a 45.
Oh, dude, that thing just blew right through.
Beautiful.
Not bad at all, and that's 60 psi. So we started off at 70 when we were cutting that. Then we went up to 80. And then we went up to 100, and it was kind of getting worse, and then we turned it back down to 60, and this is our result. I really do think this looks pretty darn good to me.
Want to try a long one?
Sure.
I just want to play with it.
Not quite. I think you were just moving a little too fast. Oh, there it is. She's gone. And you know what else? I don't know if you noticed, but you were also cutting that.
Oh, yikes.
Yeah, so it was like working a little extra hard. But, I mean, not bad.
It works.
Did it weld itself?
A little bit.
I think if the question is whether or not it can cut it, I think the answer is yes.
I agree.
If the question is whether or not we know how to use a plasma cutter, I think the answer is no.
I agree.
All right, let's move on to the next test. So moving on to the MIG portion, we're gonna go ahead and set up this machine to MIG. So we're just gonna keep pushing this top left button. We're gonna keep it on 2T. We have 2T, 4T, and then ... which I'm not sure what that is, so we're gonna ignore that. We're gonna keep that on 2T, and then the wire, I believe it's 030, so we have 023, 030, 035, and 045. So we're gonna put that at 030, FeCO2, so that's a C25 mix with steel. And I believe we can go, oh yeah, so we can do straight argon, Flux Core, no gas, stainless steel, which is a tri-mix. Then we have aluminum with argon, and then aluminum for spool gun. It says aluminum MIG and then argon. So we're gonna go FeCO2. So that's gonna be our C25 mix. Actually, no, our C25 mix is gonna be the FeArCO2 is gonna be this one on the right. And then 100% CO2 is right there on the left. Over here by the drive roller, we've already got a 10-pound spool set up. It's going through the double drive rollers. We've already moved the power cord from the cut to the TIG, MIG, and stick connector. I've already made the mistake of forgetting to switch this over a few times, so do make sure to have this hooked up. On the back side, we've got our 2 air hoses. One of them is for the air compressor, which I'm going to take off because I'm going to get confused. So this one's for the air compressor, which we don't need right now. And then the one on the left is the one that we're going to be using for the gas bottle. Again, this is the one that came included with this welder, this kit. It came with the fittings, the orange hose, and it seems like it holds the gas pretty well. I've already tested it. I don't have any kind of leaks, and I did assemble the hose myself. The little one came pre-assembled, but I assembled the big one, and it seems to be doing a pretty good job. I've already taken off the connector for the plasma cutter, so we don't need that. Went ahead and put that out of the way. And then as for the DIN connectors on the front, we've got negative to negative, and then our power wire to the positive. And then we went ahead and connected up the MIG torch. And now here on the console, we're just gonna hit the center button and hold it. That's going to auto feed the wire through the machine. We went ahead and played with a few different settings here to see if we can find a happy medium. I think we went through about 10 or 15 different settings, and we ended up on this one right here, which gave us a total of 17.4 at 50 amps. The thing about this machine is that we're on the sync setting, and so this will change depending on what amperage setting you put on here. So it's similar to like a TIG welder or a stick welder, where you set the amperage that you want to run, and then it'll select the voltage for you, and then it has a voltage offset dial on the right hand side. If you go to manual, you can go and select your voltage and your wire speed settings individually. So I think you can have a maximum of 15 meters per minute, and then you can have a maximum of 27 volts, 27.5 volts, and then you can move that up and down as you want. What we went with was the sync setting, 17.4 at 50 amps, and I think that gave us a pretty good result. Here's a close-up of the weld we just did, and you can see just how well it penetrated on the opposite side. So for me, it does look like it welds pretty well with MIG. I would definitely be pretty happy if all my welds ended up like this. So I'd say that we probably need a little bit more practice with the MIG setting on this machine, but overall I'd say the result is very passable and acceptable. So now that we've got the MIG welding out of the way, we've got to do a little bit of TIG welding and put this machine to the test to see if it actually does what it says that it does. All right, so we've got everything hooked up to do a little bit of TIG welding here, but what we don't have a lot of is gas. So we're gonna go ahead and turn this on. And we have a little bit of CFH, but not a lot of PSI, so we won't be able to TIG weld for too long. One thing to note though is that when you go to TIG weld, you got to take your gas line off of the C25, move it over to straight argon if you're welding mild steel or aluminum, and then you're going to want to move the quick connect line from MIG to TIG here on the right, and then do make sure that you're set up for TIG MIG stick on the right hand side there as well. As for the controls, we are on sync right now because we were just MIG welding, so we're going to hit the 2 arrows, and then we're going to move on to TIG high frequency right there, and then it's at 157 amps. That's going to be way too much, so we're going to go ahead and turn that down to 50, and then we're going to start TIG welding some mild steel. What I just realized is that this welder actually has gas solenoids, so it has pre-flow and post-flow capabilities. When you hit the switch, it'll activate the solenoids, and then once you let off the switch, it'll let the gas flow out for a little bit. What I can't find are any settings to change the time to do pre-flow and post-flow. So you're kind of stuck doing whatever the machine has it pre-programmed. So let's see if I can at least get an arc started, and then we'll add some filler. I'm starting to run out of gas. Yeah, it was starting to go, and it was starting to go pretty well. I definitely needed a thicker filler material than this one because it was coming out a little flat, but it would have done the job just fine if we would have had a little bit more gas. Unfortunately, we can't continue that because we were just completely out of gas, and we can't use C25 for this because it's just going to make a big old mess. We're going to have to keep using argon. All right, so final thoughts on the machines. The positives: it can do MIG, Flux Core, TIG, stick, plasma cutting. The TIG is high frequency start and not lift start, so it uses the trigger finger and not like the lift arc start feature, so that's really nice. A few negatives is that the TIG does not allow the option to install a foot pedal, and so the only difference between running a foot pedal and not running a foot pedal is that you're kind of stuck on the amps that you set the machine to. So if you put it on 50 amps, you're going to have to weld 50 amps all the way through with 0 deviation, which is not a big deal if you're kind of familiar with how to TIG. If you're learning on TIG, then you're going to have to do a lot of stopping and starting while you're dialing your settings. It's not a big deal, it's just a little bit of an inconvenience. The MIG is just a little bit noisier than what I'm used to, but it does do the job. I did notice that it's in metric instead of standard, so I'm used to seeing inches per minute. This uses meters per minute. In fact, the other DecaPower welder that I had also ran it on meters per minute, and the settings don't quite match up to the standard units. If you take your inches per minute and then convert it to metric, it's not going to give you a 1-for-1, so you're going to have to relearn the settings a little bit. But if the question is whether or not it can weld, yes, it can weld, and it welds pretty decent. I'm pretty happy with the welds that we were able to put out with this welder.
Going off, I don't know what a good TIG welder looks like, but this looks like a good MIG weld.
Yeah, the MIG welds look good.
So
I don't know what your Lincoln sounds like. My Lincoln sounds a little bit different from what the sound it was making here.
maybe a little higher
Pitched, yeah, a little bit more coarse. I think it was a noisier machine than my Lincoln.
Yeah.
And noisier machine than my Yes welder too. We didn't try out the Flux Core, but I've had, like I said, an older DecaPower welder, and I've welded exclusively with Flux Core, and it did a really good job. So don't even count that against this machine. Another negative for the machine is the funny dual roller setup. It's just a hassle having to deal with 2 drive rollers instead of 1. I understand that they want to have more grip, high performance, a second cylinder, but I mean it uses irregular size rollers, and so I haven't even seen these anywhere. This is the first machine that I've had that uses this style of roller. So I'm not quite a fan. What's lucky is that it came with 6 different roller setups, or 3 sets of 2 roller setups for this machine. And I'm not actually sure if we could just run one of these and then have it run all the way through, or if we're forced to run both at all times. Just another nitpick there, not a fan of that. But if that didn't worry you, it's not really a problem. A positive thing about the welder is that it can accept a 10-pound spool along with a 1-pound spool. By taking off this piece right here, you just undo the nut, slide this off, and you can slide in a 1-pound spool. So that is a positive thing about it. Another positive is that it came with almost everything to run the welder. It came with the airline, it came with the regulator, it came with all the power cords, it came with the TIG torch, it came with the stick electrode holder, the MIG gun, the ground cable, pretty much everything. The only thing that it didn't come with was one of the consumables for the TIG welder, and that was the tungsten. Tungsten aren't terribly expensive, but they included everything else, including a 3/32 collet, so you would assume that they would also include a tungsten, but they didn't. Lucky I still had one on hand, and we were able to start welding with that. Another positive for the machine is that it uses all standard connections in the front. Standard MIG gun connection, DIN connectors in the front, and the plasma cutter and TIG torch both share this front connection. So although you can only use one at a time, you'd really only want to use one at a time anyway. So if you're going to use the TIG torch, it only takes this connection and then the 2-pin connector in the back. And then if you're going to use the plasma cutter, it just takes the plasma cutter air connection and then the plasma cutter 2-pin connection in the back. So it's exactly the same thing. You can just choose one or the other, but you can't have them hooked up at the same time like you can with MIG and TIG, or MIG and stick, or MIG and plasma cutting. So the machine is $600 retail with a Prime Day code or whatever. It's like $520 plus tax. I think it's free shipping. So if you were to take the plasma cutter section out of it and the MIG welding or the TIG welding section out of it, a dedicated DC TIG welder is like $150. And then a plasma cutter is like $200. So if you take $350 off the $600, this is like a $250 welder. But I think it does more. I think it has more features than a standard $250 welder. So if you were to buy 3 different welders for the same price as one big welder like this one, I do think that this welder would be a little bit further ahead.
Yeah, because I'm sure there's shared components.
Yeah.
Between them. Also, when space is a problem, like my garage.
That is true. So that's another big thing, is that because we are in this particular space, we are fighting a little bit of side-to-side room, and so it's a lot easier to take one machine and stick it off to the side than it is to take 3 different machines and then find a way to put them all around the shop space. So I think price-wise, I think it's very fairly priced. It is a little finicky on how it's set up and the types of things, the types of connections that it uses, but performance-wise, I think it does a job. I don't think someone is going to be unhappy with the way this performs. I think it's right up there with several of the other machines that I've tried out. And the inclusion of the plasma cutter does sweeten the deal a little bit, because I've had more expensive machines that can do less things. So those are just my thoughts. Let me know what you guys think about this machine in the comments down below. I will see you guys all in the next one. Night Wrencher signing out.